First, the record. On the night of April 20th, 2010, a well at Mississippi Canyon Block 252 in the Gulf of Mexico lost control beneath the rig drilling it. 11 men were killed, 17 more seriously injured. We keep the camera on the engineering in their memory. This is what a rig of this kind looks like. A semi-submersible, a drilling deck carried on submerged pontoons holding station over a hole in the seabed. This is not the Deepwater Horizon. No rights-clear photograph of that rig as it stood was available, but the same class of machine at the same scale. The well is a line drawn straight down from a rig like that, 5,000 feet of water, then rock, to 18,360 feet below sea level. At the bottom, a reservoir pushing upward for millions of years. Nothing holds it back alone. A well is a stack of barriers. If you would rather understand why things fail than watch them fail, subscribe. A new failure is drawn here every week, each one a reason you are safer than you know. Here is the first flaw, 18,000 feet down. The deepest barrier is the tail of cement in the shoe track, about 6 9/10 barrels in 189 feet of casing. It was nitrogen foamed to keep it light enough not to fracture a fragile formation. The Commission's testing found that foam recipe unstable. The nitrogen could break out and migrate, leaving cement of the wrong density in the wrong place. Channeled, contaminated, or simply over-displaced past its target. Nothing on the rig floor could see any of it. It is 18,000 feet down, and it is invisible. Which is exactly what a negative pressure test exists to reveal. You take the weight off the well, replace the heavy mud with lighter seawater, and then you watch. If the cement holds, nothing flows and no pressure builds. If it leaks, the reservoir answers. The well answered. The drill pipe held about 1,400 pounds per square inch, while the kill line, open to the same well, read 0 for 30 minutes. Two gauges on one well cannot honestly disagree by 1,400 pounds. It was explained on the rig as a bladder effect, and the test was declared a success. With the test signed off, the mud column was pumped out of the riser. The last barrier was removed on the strength of an instrument read backwards. Hydrocarbons entered, and as they climbed, the pressure above them fell. The gas expanded and moved faster the higher it got. At about 21:38, it reached the riser. At about 21:41, the crew reached for the last defense, the blowout preventer on the seabed. Two annular preventers on top, beneath them 5 rams, 3 variable bore, 1 casing shear, and 1 blind shear ram, 2 opposed blades meant to cut the pipe and seal the bore in one stroke. Closing the rams did something nobody applied on purpose. It set an enormous pressure difference across the drill pipe wall, loading the string as though something were pressing down on it. The Chemical Safety Board named this effective compression, about 115,000 pounds. The pipe buckled sideways, out of the blade's reach. Here is the line. Out of the reservoir, through the shoe track cement, past the float collar, up the casing, and up the riser, drawn once. And a second line at the seabed. The blades close, the buckled pipe is not where they are reaching, and they punch it instead. What happened on the rig above is not drawn here. On the preventer itself, the record is divided, and worth saying so. DNV concluded that when the blind shear ram closed, the pipe was already buckled outside the reach of the blades. The Chemical Safety Board uniquely placed that firing on the night of April 20th itself. They agree on the buckle. The pipe was off-center, and that is why the seal was impossible. They differ on how much the miswirings and battery failures in the control pods mattered. The joint investigation team spread responsibility across the operator, the drilling contractor, and the cementing contractor. The Chief Counsel's report records that industry experts dismissed the bladder effect as fiction. and the National Commission wrote that this was not a series of aberrational decisions. Systems, not scapegoats. Here is what changed. The agency that both leased the seabed and policed the drilling was split, leasing to the Bureau of Ocean Energy Management, safety enforcement to the Bureau of Safety and Environmental Enforcement. The office that collects the money no longer signs the safety permit. The well control rule added blowout preventer testing, shear ram verification, and real-time monitoring. SEMS required protected stop work authority. And capping stacks now stand pre-built and waiting. In 2010, one had to be designed during the spill. Failure mode, barrier failure, shoe track cement, and a seal never achieved at the preventer. And a rule for reading a test. If two gauges on one well disagree, the well has not passed. Nothing breaks without a reason. Now you know this one. Drawing filed. Like and subscribe to support the channel.